Welcome. Welcome to Discrete Maths course. My name is N.L. Bhanamurthy.
And my name is Venkatakrishnan Ramaswamy, and we are the instructors for this course. Discrete Mathematics is a basic course in computer science that introduces some basic mathematics that's needed for other computer science courses primarily. Here we will briefly discuss a couple of sort of real-world examples just to illustrate discrete mathematics.
Given these 10 numbers, if you are asked to put them in the descending order, perhaps you may come up with a procedure or sequence of steps to put them in the descending order. Maybe that procedure is working for this simple example of 10 numbers. For it to work for a generic example, you need to prove the procedure that has been put forth there. In mathematics, there are various techniques of proving a given statement. Techniques like mathematical induction, proof by contradiction, contrapositive proof, all these things are there to prove a given statement. We will explore proof methodologies in this course. After proving the procedure is correct, we will have to say how efficient the procedure is. Functions play a vital role in establishing efficiency of a procedure. We will also see functions in this course.
Here's another example. So what you see on the screen is the railway map of India, right? Which incidentally, Indian Railways is one of the top 5 largest railway systems in the world. For example, the state of Andhra Pradesh, which is a state in India, has a new capital now. And the Indian Railways might wish to run a train from the national capital, which is New Delhi, to Amaravati, which is the new capital of Andhra Pradesh. Now, as you can already see, the railway network is fairly dense, and the Indian Railways might wish to have a route that this new train is going to take that is the shortest, right? And in order to do so, you can already see that they will need an algorithm, right, which is a procedure to determine the shortest path according to this network from New Delhi to Amaravati. So the railway network itself is an example of what we technically call a graph in mathematics. And in fact, there's an entire subfield called graph theory which deals with graphs. And we will cover some of it, at least the basics of it, in order to get to a place where we can talk about graph algorithms, which are algorithms that run on graphs, which end up actually being very widely applicable. So let's just quickly go through an overview of the topics that we will cover in the course. So in week 1, we will start off with the basics of logic, following which we will talk about proofs and proof methods. And at the end of week 1, we will cover some proof methods, and which we will continue at the beginning of week 2. We will end week 2 with a set of videos on sequences and summations, which are also very important.
Sets are fundamental mathematical structures on which most of the discrete structures are built. We will understand sets, functions which are required during your journey through computer science. In week 3, we will understand sets and functions. The mathematical structure relations play an important role in modeling databases and of course in other branches of computer science. We learn relations in the 4th and 5th week of the course. We also go through various counting techniques, well-known pigeonhole principle and recursive relations in 6th and 7th week.
In the 8th week, we will start off with the basics of graph theory, and we will start with some real-world examples, and we already saw one early in this video. And following this, we will discuss rigorous definitions of graphs and specific types of graphs. We will also talk about specific structures defined on graphs, such as paths and cycles in week 9. And also problems on graphs, such as graph isomorphism and graph coloring, which we will also continue in week 10. Towards the end of week 10, we will talk about some abstract algebra, topics such as groups, rings, and so on. Now, to do well in this course, we encourage you to watch the videos carefully and make sure you fully understand them. Please also read the reading material after watching the videos. Now, together this should enable you to already do well on the quizzes. Now, if you find that you are unable to do well in the quizzes, do consider revisiting the videos and also the reading material.
The reading material and the textbook by Rosen are very good. We encourage you to read them carefully. Do also some of the exercises at the end of the section in Rosen. Of course, we'll cover everything from the beginning. So, if you are following diligently, we expect that you will be able to do very well. With that, we welcome once again.
And we look forward to seeing you in class as well as in the live sessions. Thank you.